So as we mentioned before, another type of data type are sequences or lists and arrays. So we will be first talking about lists, which are technically defined as zero-indexed collection of data elements. What does zero-indexed mean? So if you look at the array on the bottom, it means that actually the array elements are numbered starting at 0. So even though 7 is our first element in this array or list, it is in the 0th position. And even though 4th is technically our second element, it is in the 1st position, and on and on. And you will notice that even though that there are 7 elements here, you can go ahead and count it, there's actually no 7th position. It just ends at the 6th position. So lists, in comparison to arrays, are native to Python. And so the syntax for these lists are these brackets that you can see, and then our 0th element first, then our first element, then our second element, and so on and so on. And so one example of a list is our odds list here. So odds equals 1, 3, and 5, where 1 is our 0th element, 3 is our first element, and 5 is our second element. And so when you're looking for the features of a list, like, for example, the length, we would actually call len and then parentheses over odds, which is the variable we assign to that list. You can also just put 1, 3, and 5 in that list format inside that, and it would still return 3, since there are 3 elements and our array or list is a length of 3. And you'll notice below in the mixed array that actually, even though odds is all numbers, you don't actually have to do all numbers for the elements of a list. It can be all different. So 1 is an integer value, high is a string value, and true is a Boolean value. So it can be a ton of different things. As you can see in the evens array, 2, 4, and 6, if we call the 0th position of evens, which is, again, 0 indexing is the term for it, we will receive the value of 2. Similarly, if we call evens bracket 1, where we look for the first position, it would return 4. So, and there are some other list operations that are important to know that we will compare later with NumPy arrays or non-native lists in Python or sequences. So in this case, we can see that we have a list of 8 and 10. So it's an array of 2. And then as we remember before, evens was what we assigned to 2, 4, and 6. So what happens if we add it and then multiply 2 to the end? So we can see that actually this just adds all the arrays together into this massive list. So, and if we multiply lists, it just creates multiples of them to be added together. So we can see here it goes 8, 10, and then evens was 2, 4, 6. So there's 2, 4, 6, and because it was multiplied by 2, there's another 2, 4, 6, which is interesting. You would assume that if you multiplied it by 2, it would be 4, 8, and 12, since 2 times 2 is 4, 4 times 2 is 8, and 6 times 2 is 12. But that is not the case with list operations, or lists. Similarly, we can create 2D lists, for example, in our pairs list here. So you can see that there are outer brackets, and then inside those outer brackets, there's 1, 5, so one list, and then 9, 6, another list. So if we just call the first position of pairs, we would receive 9, 6, because we would look immediately within just the outer bracket that is on the outside. So 1, 5 would be our 0th position, and 9, 6 would be our first position. So we receive 9, 6. But if we call another brackets, we can look within this 9, 6 to look at 6, since 6 is the first position in the list 9, 6. In comparison, we have arrays, which are pretty similar in concept, but if we apply functions to it, they act a little bit differently. So arrays are constructed from the NumPy Python library, which is more advanced than native Python lists. And we typically import NumPy so we can get these more advanced functions. So how do we make arrays? So instead of that traditional bracket, we actually put lists into this np.array function. So if you can look at odds, instead of that typical 1, 3, 5 that we would normally do, we put that within np.array, and it becomes an array. To look inside the length and get that feature of an array, we would instead do the variable name dot length in just that empty bracket. So in this case, 1, 3, 5, of course, is a length of 3, so we would return 3. And we can see this same thing to be true with our mix array as well. Same values as before, except it's within np.array. And as we can see, np.array also supports lists or arrays of different data values or different data types. So as you can see, our evens array is also here, but it's constructed a little bit differently. So another way to construct arrays is np.arange, which takes in a start number, an end number, and a step number, or what is added to each start value. So for this np.arange, we can just talk through it. So our start number is 2. So as we can see, 2 is less than 7, so it becomes our first array value. And then because our step is 2, we do 2 plus 2, which is 4. 4 is less than 7 as well, which means it is acceptable, and so it gets added to the array as well. So now we have 2 and 4 in our array. And so we add another 2 to it, and we receive 6, since 4 plus 2 is 6. 6 is also less than 7, and so we also add this to the array. And then we continue. 6 plus 2 is 8, however, and 8 is greater than 7, so we stop there, and our array will just consist of 2, 4, and 6. And as you can see in the example, we also index or find the value of our positions a little bit differently as well. Instead of those typical brackets, we use evens.item0 to find the position of the 0th index in evens, and which we can see again is 2. And it uses that same logic of 0 indexing, where the first item is in the 0th position. And looking at some other array operations and comparing it to before, we can see that with arrays, actually now we can subtract values of different arrays, so if they're the same length, and perform mathematical operations on them. So as you can see here, np.array135 subtracted by np.array111 would result in an array that is 0, 2, and 4. This is because 1 minus 1 is 0, 3 minus 1 is 2, and 5 minus 1 is 4. We can use some other operators on it as well, including comparison operators. So if we were to compare np.array149 and np.array246, we would compare 1 is less than 2, which is true, and so our first value in our resulting array would be true. 4 is less than 4 is false because they're the same value, so return false. And then 9 is less than 6 would return false as well because that 9 is greater than 6. So it would have a resulting output array as true, false, and false. And finally, we don't actually need arrays of the same size. We can also just use constants like before. So np.array135 is greater than 2 compares 2 with all those values of before. So 1 is greater than 2 is false, obviously, since 1 is less than 2. 3 is greater than 2 is true, so it outputs true, and 5 is greater than 2 is true, so it outputs true as well. So our resulting array would be false, true, and true. Similarly, we can also use another operation, a mathematical operation, and actually do multiplication or division, subtraction, or addition. So in this case, we chose multiplication, so we multiply 2, and unlike before where it gets duplicated with lists, if this was a list, it would be 135, 135, but in this case, we can actually perform mathematical operations on arrays. So it becomes 1 times 2, which is 2, 3 times 2, which is 6, and 5 times 2, which is 10. And so we referred earlier to this idea of ranges, another way to create arrays using the np.arange function. What's interesting to note is that you actually don't always need, even though it's asking for 3 numbers, you don't actually always need those 3 numbers. There are some default values that that NumPy can assume for you. So if you only use one value, it will assume it's the end value. So np.arange will take in, if it takes in a single value, it will assume it's the end step. So it will default pick the start position as 0, and it goes up to the end, and it will assume your step is 1. So if you picked an end of 3, for example, it will start from 0, and your array will be 0, 1, and 2. Similarly, if you picked np.arange, and then you only put 2 values, it will assume it's the start and end. So if you did np.arange to 5, it would assume that your step is also 1, so your resulting values or your array outputted would be 2, 3, and 4. It's important to note that the end value is usually not included if it's equal. So how it compares is if the value generated in your step is less than the end step, then it will be included in the array. And finally, as we saw before, we can also just have our start, end, and step, which actually, and so we can specify a step that's not 1. So this is pretty intuitive, as we mentioned before. So I will not re-go over this, but it's something important to keep in mind. And something also important to note is that range always includes start but excludes end, as I also touched upon earlier. So some examples of these that are more written down is np.arange3. So as you can see, it includes the start, which is 0, but does not include the end, which is 3. Another example is np.arange15, which starts at 1 and ends right before 5, so it does not include the end again. And same with np.arange3, 13, and 3, that has a step of 3 and ends at 13 and starts at 3, as we can see below.